Hi, my name is Rangga Pramudya and I'm a student from Department of Physics at UIN Sunan Gunung Jati Bandung. And for today, I want to explain about movement of a mass in a system using a Newtonian method. So, without further ado, let's get to it. This is the system that I make. The system contains a metal rod, a spring made out of a rubber band, a plastic rope, and there's a mass with a hook in it. So how is this system moved? So when I give this mass over here a force in this direction, in diagonal direction, so when I release it back, the spring will pull it back. After that, it will push it back, and so the spring do it for a couple of times. So back and forth, back and forth. So the spring is oscillating, and the rope here, there's a tension in it, so this rope makes the mass over here moving in a circular area. So it moves from here, 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 and here, and here, 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 over here, like that. So the mass here doesn't go anywhere. Well, for a better visualization, I will play how the mass is moving in a video. So the next question is, how many constants there are in the system? In this system, there is one constraint. It is because this rope right here. So the rope makes the mass over here moving in a circular track. So it's moving to here, here, here. The cursor does. And because of that, the mass movement is limited by this rope. The next question is, how many degrees of freedom are there in the system? So first of all, let's talk about degrees of freedom. To put it in simple, degrees of freedoms are what dimension the system moving minus how many constants are there. Well, in my case, the system is moving in 2 dimensions. So it's moving in x and y plane and only have one constant. So 2 minus 1 equals 1. So the system only have 1 degrees of freedom. Okay, so for the last question is to find the equation of motion for the system. First of all, let's break down all the forces first. First, we have the spring, forces done by the spring right there. So the forces given by spring for a Hooke's law given up, F equal negative K times Ls negative LO. So Ls is the length of the spring in here, and LO or L0 is the natural length of the spring. So it's the length of the spring before we give it a mass and a force. And this one right here is the vector unit of the spring. So this one is giving us the direction of the spring is moving in x and also y direction. For the second one is the tension force. Tension force given by the rope. This one right here. So F tension, or the force done by tension, is equal to negative T times the vector unit of the rope. So it's giving us the movement done by the rope in x and y direction. The third force is the gravitational force. It's gravity. It's only work in the y direction, so it's negative mass times g, where g is the acceleration of gravity. And for the final one is the external applied force. So this is the force that I given. Well, as you can see here, the force is in the diagonal direction, so it has both x and y component, while for the x one is the f times cos theta and y is f sin theta. You can do this by doing the trigonometry. Well, we put it into Newton's second law, mx squared, mx double dot. Well, it's the mass times the acceleration in x direction. Negative, this is the spring, and this is the tension force, and this is the applied force. Same for the y direction. Forces given by the spring, the rope, and then the applied force, and also in y direction we have the gravitational force. So that's all for me. Thank you for your attention and thank you for watching this video. See you and have a good day. Bye bye.